And now we're on question 10. Question 10 says, EHGF is a rectangle. Now we have HE, okay, produced x squared centimeters to n. Okay, so HE is produced x squared centimeters to n. Okay, so that is being produced to n. Then they tell us that EH is produced x squared centimeters to p. So EH is produced x squared centimeters to p. Then they tell us that NF produced intersects PG at M. Okay, so those two get produced and they intersect at M. Then to form an isosceles triangle MNP. So this is an isosceles triangle. So they're already telling us that this and this, those are equal. Okay. With, of course, they say it NM being equal to PM or MP. D right there lies on NP, where MD is perpendicular to NP. So we have perpendicular. And then they tell us that NP, that is 4 units. And MD is 3 centimeters. Okay, they're all in centimeters. So MD is 3 centimeters. Okay. 10.1, you need to show that the area of EFGH is given by A of x is equal to 6x squared minus 3x cubed. Okay, so let's work with that. Let's see what we're going to get there. Okay, so let's just establish a few things. First of all, they made it very clear this is a rectangle. They said the rectangle. So we can consider all the properties of a rectangle on this. Okay. Regardless, they told us that these two lines, that and that, are equal. So that line and that line. So we have an isosceles triangle. And that's x squared, that's x squared. This is a rectangle. And we can see this is perpendicular. So this is 4 units. So already you can see that these two triangles are literally the exact same triangles. This one is just flipped around. So they're basically, those two triangles are congruent. Okay, so those are congruent triangles, and we can actually see them because you see you have a side being equal, we have a common side and an equal angle. They're both 90 degrees, so they're congruent. But this is not Euclid, so we don't have to give them reasons. We just have to conclude certain things. Okay, let's actually focus on, because I don't like to find things. I know I'm just analyzing a lot too much here. It's just because the shape looks intimidating, that's really all. But let's actually focus on what we would do to find what they told us to find. They said find the area of that rectangle. Naturally, to find the area of a rectangle, you just take the length and you multiply by the breadth. So if we're looking at that, they already call that B. So we need to take the length, which is EH, and we need to multiply by the breadth, which is EF. And now I don't have to go searching for random things. I just have to focus on what I need to find. I need to find EH and EF. So we'll look at that. How do we find EH? Okay, that one seems quite simple to find. They told you this entire thing is 4 units. From here to here is x squared. From here to here is x squared. You see the remaining part is EH. So to find EH, you would just take the entire 4 units and you minus it by this little part, the x squared, and you minus it by that other part, the x squared, and you'll be left with your EH. So EH in terms of x is 4 minus, see, negative x squared minus x squared is negative 2x squared. Okay, so we have EH, check. Now we just need to find EF. Let's look at this. How can we find EF? Okay. Since this is part of a rectangle, a rectangle has certain properties. So let's actually consider the properties of that rectangle. First of all, a rectangle has 2 pairs of opposite sides being parallel. So that's parallel to that. And this is parallel to this. Sorry, I should give that a different type of marking for parallel. Okay, how does that actually help us? The goal is to find EF, so everything I should use should be to find EF. Let me look at this for a while. Okay, so when I looked at this for a while, at first, I was trying to consider, using like Pythagoras or something like that. But that's not really possible because unfortunately, like if I try to use Pythagoras on this, I need to have NF. Then I went on a whole spree of looking for NF and I did not find NF. So that's clearly not working. So what I'm going to go towards, because we have parallel lines, is I'm going to try and see, because I also noticed, remember that they told us that MD, right, is 3 units. Let's keep that in mind. They gave us that for a reason. There's no way they just put it there so that we can't use it. So because of that, I thought maybe we can use the proportionality theorem. If you tilt your head this way, right, you see this is a big triangle that you have. Because that's a triangle that you have, you can use the proportionality theorem. Now here's the thing about this line MD. It is a vertical line. We know it's a vertical line because it is perpendicular to our base, right? And our base is part of a line with a rectangle. A rectangle is made up of a vertical and a horizontal line. So this is a horizontal line, so this is vertical. Because it's vertical and these ones are vertical, they're all parallel. So if you tilt your head, let me just actually put that in black. So parallel, parallel, right? If you tilt your head and you look at the triangle NMD, do you see that you can use the proportionality? Well, it's not proportionality theorem I'm seeing here, because if it was proportionality, I would have to kind of like use this, maybe NF and NM, right? And then NE and ND. And that's not really possible because, yeah, sure, I can find NM because of Pythagoras, but I can't really find NF. That was the first headache in the first place. So it's not proportionality. Instead, you can try and use similarity. Look at these two triangles. Look at NEF and look at NDM. Those two triangles will be similar. You would know this from the similarity proof. I also have a video on that. Okay, so I'm not going to have to prove anything. This is not Euclid. So what I'm going to say is, and I'm just going to write this down for the sake of it helping me find my proportions. I'm going to tell them that triangle NEF is similar to triangle NDM. Okay. And here's just a brief explanation for why they're similar. We have parallel lines, that's corresponding angles. Those two angles are equal. You have a common angle being equal. And by default, the third angle in the triangles would be equal. So they're similar. And then we have, what we're going to do is we're going to use these proportions. Now, I don't know how it's going to work. I just know I need FE. And so I'm just going to try my best to work through that and hopefully it can help me find FE. So when you have similarity, when you have two triangles being similar, the sides are going to be in proportion in this way. So you see the side NE over ND. So you see NE over ND would be equal to the side, the proportion will be equal to EF over DM. And that would be equal to NF over NM. Okay. And M. So I'm just going to fill in what we have and hopefully we'll be able to find one for FE. We will definitely will be because it's structured like that. So NE is x squared. So we're going to fill in. That's x squared. And D, what is ND? ND. Okay, so you see with ND, because this is a congruent, you see I showed you that these two triangles are congruent. You have an equal side, common side, and an equal angle, right? It would mean that this little part ND is 2 units, and that one is also 2 units, cut in half since it's a total of 4 units. So we have that. We have ND, it's 2 units, 2. Don't need reasons, it's not Euclid. EF. Now, where's EF? EF is this. What is what we're looking for? It's fine if it's empty. No problem, because we're looking for that. Over DM. DM is 3. Yay. So this is actually looking very good. I would have gone ahead and go and find these, but I see I don't even need them anymore. I just need these two. I'm going to work with that. Okay. So I'm just going to erase that. Don't really need that. This is, of course, because of similar triangles. Okay, the reason I say I don't need that, because you see that here, the only thing missing, the only side missing is EF. Everything has a value. This is x squared, but it's still in terms of x. So to find EF, we're dividing by 3. So to get rid of this 3 so that EF is alone, you'd multiply both sides by 3. And then it would mean that you're left with EF because the 3's would cancel. And here you'll be left with, you have 3 and x squared over 2. You can write that as 3 over 2x squared. That's EF. Finally, we found EF. So there we have our two sides that we needed, and we can go ahead and use this now. So again, we're saying that the area is equal to EH, which we know is that, times EF, which we know is that. Okay, because this is one term, I'll write it first. That's x squared being multiplied by something that has two terms. So you need to use brackets so that it can multiply into both terms. So that's 4 minus 2x squared. Okay. Then we have a is equal to, we're going to multiply. So if you distribute in 3 over 2, let me actually show you what this is going to do, times 4. What actually happens is when things are common, they cancel diagonally and also top and bottom like that. So diagonally, do you see that 2 is common? You're saying 2 divided by 2 is 1. 4 divided by 2 is 2. So all that's left is 3 times 2, which gives you 6, right? So in the numbers, that all that's left is 6. Then you still have x squared. Then if you multiply that as well, let's see what happens. So 3 over 2, I'm working on the numbers first, times negative 2. Do you see that diagonally 2 would cancel? 2 divided by 2 is 1. 2 divided by 2 is 1. So this is a negative 1. 3 times negative 1 is negative 3. And then, of course, there are x's. So x squared times x to the power of 2 as well is x to the power of 4. And there we go. That's a of x. I've been calling it a of x. And we finally found the value of a of x. Okay, so that's that. 4 marks. Moving on to the last question of question 10. Okay, and then the last question is calculate the maximum area of rectangle EFGH. Okay, so this is the area of it. To find the maximum area, you first have to find the value of x for which this area will be a maximum. Okay, so we're going to take our function, and to find out its maximum x value, you're going to derive the function, basically finding the gradient, and then you're finding where the gradient is equal to 0, because at stationary points, this is where this graph is, neither increasing nor decreasing. That's just those are the points that are sitting still on the curve. So on most curves that you see, these would be really key points to find whether this is the maximum or the minimum. Okay, so we're going to find the value of x for which this is going to be a maximum. To do that, you're finding the gradient of the function, and you're specifically finding where the gradient is equal to 0. So we're going to say a prime of x is equal to, that will give you, so multiply, we get 12x. Then negative 3 times 4 is negative 12. And we have x to the power of 4 minus 1, which is 3. Okay, so this is our function derived. Then you're going to set it equal to 0 so that you can find that maximum or minimum point. Okay, those turning points, the stationary points, is equal to, we have 12x minus 12x cubed. I can take that over, no, not really. Since they both have 12 and x, just take out 12x as a common factor. Then you're left with here, if you divide that by that, you get 1. If you divide this by that, you get negative x squared. Okay, so this is what we have. So we can say this can be factorized further. You can use difference of 2 squares if you want. It's not necessary. So I'll just say 0 is equal to 12x, or 1 minus x squared is equal to 0, right? Because they're being multiplied. If you have something times something and they give you 0, it's either that this one is equal to 0 or that one is equal to 0. So divide both sides by 12, and then you see that here 12 cancels. 0 divided by 12 is 0, so it means x is equal to 0. That's one solution for x. And here I'm just going to do this simple way, not the difference of 2 squares. So take negative x over, it becomes x squared. Square root both sides, but because this is an equation, you must say plus minus. So x is either equal to positive 1 or x is equal to negative 1. Okay, how do we know which one is our maximum? Well, this is not, a normal function that we're used to seeing. It's not a parabola or cubic function. So all you can do is really just substitute. We're going to substitute and see which one works. And I try a of 0 into our function of a of x. What do we get? I get 0. So that's just 0. If you try a of 1, a of 1 and a of -1, they're going to be the same thing. See, this is the reason why. Because here the x gets squared. So even if it was negative, it will become positive. And here the x gets raised to the power of 4. So even if it was also negative, it would be positive. So these ones will give you the same answer. So it doesn't matter actually. You can take either one. So let's try a of 1. If you substitute 1 into that, let's see what we get. We get 3. Okay, 3 centimeters squared, of course, because it's area. If you change it to, this is what I was saying, if you substitute -1, you're going to get the same thing. You see that a of -1 is also 3 because of that squared and that 4. So as you can see, the maximum out of that, the highest area that we can get from that shape would be the 3. So we can tell them that the maximum area, okay, is 3 centimeters squared, since they told us all of that was in centimeters. So that is the end of question 10, and that is it for calculus.